So, so we are discussed about the one-way slab and two-way slabs. Okay. So for one-way slab, that is there is two types of slabs will be there. Okay. So two-way slab is less than two. That is less than or equal to two. That is known as two-way slab. See, uh, some questions will be there. What do you mean by nominal mix and design mix? How to access the quality of water? Depends of the pH value. Okay. Then what are the beam size and minimum dia of bars and curtailment rules? Then cover of RCC members like that. So many questions will be there. So see, two-way slab is Ly by Lx ratio will be less than or equal to 2. That is known as two-way slab. And greater than Ly by Lx is greater than 2 means it is known as one-way slab. Okay. So this is will be the flow diagram and see development length. We already discussed design mix. Then this will be the uh, we already discussed these things. See the properties of steels. See this is the stress strain ratio. See this is the hardening part and this is the softening part. This will be the rupture. This is the lower level. See maximum stress will be here. Upper yield point is here and proportional. The stress is proportional to Hooke's law. This is known as proportional limit. Okay. Then see already discussed about the flexure stress and diagonal cracks. See this is load combinations, design aspects in slab. See this is the curtailment details that is 0.15 L1 and for bottom will be 0.25 L1. Okay. So this is the curtailment details of slab. See, whenever the slab thickness is 150 mm, the bar diameter shall be 10 mm for normal spacing. Slab thickness can be 100 mm, 110 mm, 120 mm, 125 mm and 150 mm. See, the maximum spacing of main bar shall not exceed the 225 mm. If roof slab means same thing. Say 150 by 200 mm. Okay. So for this slab, roof slab provide minimum percentage of 0.12 percentage of slab cross sectional area. See. This is the distribution bars and this one will be the main bars. Okay. See this is the distribution bars. The curtailment will be 0.1 L. Sorry. See. This is the bend up bars. See 0.15 per into L1. The curtailment details here. This is the 0.5 and this one will be the distribution bars and this will be the dot line will be the main bar. Okay. Then beam details. See for curtailment of the slab, see 0.15 you already know these things and beam member plinth beam. This is the main thing. That is depth of beam varies from L by 10 to L by 15. Generally, the plinth beam have 15 to 18. That is overall depth ratio. For tie beam 18 to 20 and for floor beams 12 to 15 and for grid beams 20 to 30. In 230 mm width, maximum 4 rods can be accommodated. That is with 2-legged stirrups also. If you want to put extra rods means we can put the second layer for that is to increase the beam depth accommodated in second layer. So maximum 5 rods with 4-legged stirrups. Okay. So we can use 25 mm dia and minimum 12 mm dia bars. Okay. If we use 32 mm means it is very difficult to bend. Okay. So this is for a beam. Flexion means beam. See, as usual, this is the main bar. Okay, this is the intermediate support. Okay, this is the sagging. Bending moment is there, no? Sagging bending moment. Okay, this is the support. Okay, and so these are the bars. See, this for the cantilever, being designed for cantilever. That is, it is for torsional bending. Okay. See, next one will be the column. Design aspects in column. Okay. So minimum size of the column will be 230 mm by 230 mm. Sometimes it may be 200 mm by 200 mm. Okay. So minimum 0.8 percentage of steel, 4 numbers of 12 by I in rectangular, and 6 numbers and 12 mm in circular column should be adopted. Okay. The column size is large, 0.8 percentage of minimum size required to carry the axial load. It is in IS 456 2000. Generally 40 mm cover can be used. Okay. The column width by breadth to be larger than beam width. No overhanging beam is recommended. So strong column, weak beam concept shall be adopted. So the type of columns in, see, types of columns in a multi-story building. See, this one is both is having the end column will be the biaxial and the intermediate will be the uniaxial. Okay, so this will be the uniaxial and this will be the axial plan of multi-story building. Okay, unbalanced moments in a frame. Horizontal unbalanced movement in columns, axial, uniaxial and biaxial. Vertical unbalanced movement in columns and columns terminated at roof like that. So discontinuity edge of continuous beams, non-uniform length of the beams like that. So axial load, interaction diagram for design of RCC column C. We can use the chart also in SP16. The chart will be there. Okay, we can interpolate the curves, that is a load and moment of resistance. We can use this one. Okay, but it is an approximate method. It is an approximate method. Without using the formulas, we can use the chart and we can find that one. See, here it is an axial compression in y-axis and x-axis bending moment. See, the first region will be the minimum eccentricity, that is E minimum, this part E minimum, and second region will be the compression control, that is E balance here, and third one will be the tension controls here, this part. Okay. So it is the interaction diagram for the design of RCC column. Okay. Then typical arrangements of column ties. See, this is the simple tie. This one. Okay. This is the two ties. Okay. See, this is the lateral ties and links. Both are. Okay. So typical arrangements of column and ties. Lateral ties. Right. So then next one is design aspects in foundations. So typical details of footings. See, pedestal around column, starter bar that is less than 300 mm, splicing of starter bar, minimum depth of footing edge. See, this is a section view, this is the plan view, this is the plan, and this is the sections. Okay. This bar is known as starter bar. Okay, and this one is the column. Okay. First one is isolated footings. Okay. So the angle of pressure distributions to the depth of soil is 45 degree. Hence the intensity of pressure reduce the over depth because the size of the area is influencing is increasing. So the applied pressure due to water table is to be verified. This is a serious failure at larger stage. So strip wrap foundation increase the depth of influence of pressure. Hence they check for soil strata down below. If the bottom strata is wet, do not go for strip foundations. Ductility. A ductile material is one of that can undergo large strains while resisting the loads. Ductility implies the ability to sustain significant inelastic deformation prior to collapse. The brittle material or structure is the one that fails suddenly upon attaining its maximum load. Ductile material properties. See, this is the brittle material. This is the force and elongation of the bar. See, final elongation is small. Okay. So this is the maximum force. This is the ductile material. Okay. So loaded chain here. Original chain. This is the loaded chain. Okay. This is the ductile link. The brittle links. But it does not yield in loaded chain. Okay. Forces in members due to earthquake. See, this is a gravity load and the earthquake load, and this is structure member. This one is tension, and this is also tension. So this is the reverse tension and compression members. Okay. This one is weak in beam and this one is column. Okay. This one is shear failure of members due to earthquake. See, column beam like that, flexion beams, shear failure like that. Okay. Then what makes earthquake resist ductile structures here? See, a 135-degree hook shall be provided in lateral reinforcement. Lapping zone shall be less moment region of the member. Closer ties near beam column junction. And development length LD to be considered carefully. And confined reinforcement provided where earthquake zone is other than zone 2. Tackling details in a beam to resist the earthquake. See, total amount of steel from calculations. This one is. And spacing, here the spacing horizontal spacing, this is 10 times of the diameter of this stirrups will be there, and this is the beam spacing is not more than 150 mm. Okay. This is the ducting details in a column to resist the earthquake. Okay. And case study, that is if take a case study in Mugalavaikom, Chennai. See, out of 37 columns in basement area, 22 columns were overloaded and pulled out of the reinforcement at beam column junction is the main cause of sudden collapse. Okay. So taking necessary precautions in beam column joint. The very important is beam column joint only. Could have given warning before the collapse of the building. It is very much essential to construct the ductile building. Opportunities, see, so many opportunities we are having. Construction manager, planning and coordinations, project management, quality control, building and quantity surveying, contract management, structural consultant, soil consultant, estimations, and building materials, surveyor, valuer, arbitrator, diagnosing the strength, structural health monitoring, equipments, plant and machinery consultant, training and development of soft skills such as communications, management, IT skills, social responsibility, safety, environmental aspects. See, so as a civil engineer, we can do as a surveyor, soil engineer, quality surveyor, project engineer, planning engineer, and structural engineer. So we are having different in so many kinds of opportunities we are having. Okay, see, who is an engineer? Scientists dream about doing great things, engineers do them. Who told? James A. McNair. So, a good scientist is a person with original ideas. A good engineer is a person who makes a design that works with as few original ideas as possible. So, engineers participate in the activities which make the resource of nature available in a form beneficial to man and provide system will perform optimally and economically. Remember, your work may be only to sweep a railway crossing, but it is your duty to keep it so clean that no other crossing in the world is as clean as yours. So, up to we have discussed beam and slab designs. Okay, so in future we can go for next and also column also we discuss. So detailing we can next class we can do the design part, that is problems. Right? Thank you. Okay, so before closing, you have to. I am going to say some other basic tips for design. So generally, see, another one, creators or builders. That is, we creators or builders. We are dedicated to the idea of building a beautiful world so different and so superior to the present. One that we creators of this generation will go down in history as the revolutionaries who assured in the golden age of mankind. That has been lesson. Always believe in yourself. A bird sitting on a tree is never afraid of the branch breaking because her trust is not on the branch but on its own wings. Always believe in yourself. Okay, so this is the good proverb, I think so. Always believe in yourself. We are having so many opportunities in civil engineering. See, this is the best example slide for this one. See, we can go for construction manager or project management, quality circles, okay, then quantity surveying, structure as a structural consultant, soil consultant, a surveyor, valuer, and also structural health monitoring. What do you mean by structural health monitoring? Means we can easily sometimes the cracks we can't find easily. For example, bridge under that one in Texla we can't see the monitor, we can okay, so from that we can use the structural health monitoring process. Okay, so it's used as signal processing sensor. It is used as a sensor. Okay. Okay, so this is the main things. So before that, hmm, see, general types of staircase. Staircase is also available. So many staircase. Dog-leg staircase, like that we can quarter turn stairs, straight stairs, open well stairs, spiral stairs, helical stairs, like that. Okay, so this is known as a staircase. Okay. So as an engineer, you have to plan. Planning is very important for that engineer. Okay. See, for survey means we can do our surveying things and surveying leveling. We can do this one, and soil we can know the soil, because soil is very important for foundation engineering. Okay, the quantities and estimation is very important. Project engineering means can control the planning and scheduling for that one. This is the planning, this is the same this is a project engineer, this is the planning and engineer. Structure is builds design of beams, slabs and columns, as well as the foundations. Okay. So far we are discussed, and we are also discussed about the opportunities of civil engineers. Right? We will discuss in next class about the design part. That is problem we can design. We can discuss. Okay. Thank you.